Understanding sleep-disordered breathing. A good night's sleep is essential for your health and well-being. Sleep is a time of restoration for your body. While you sleep, your cells are awake, repairing themselves. Sleep-disordered breathing, or SDB, is one of the main causes of poor sleep. ResMed has created this presentation to help you understand more about the common types of SDB events, what these are, how they occur, and what effects they may have on your health. Breathing brings air into the lungs so that oxygen can be transported throughout the body via the bloodstream. Oxygen is vital for organ function and general health and well-being. If you have SDB, airflow to your lungs periodically decreases while you sleep. Changes in the upper airway are the most common cause of reduced airflow. If you have SDB, the patency or openness of your upper airway keeps changing as you sleep. It may be fully open, it may be narrowed to some extent, which we call flow limitation, it may vibrate, which is heard as snoring, or it may be completely blocked. This is called obstructive sleep apnea, or OSA. During this presentation, you will be able to see and hear how these changes affect your body. But first, let's take a closer look at normal breathing. Normal breathing during sleep occurs in a familiar, regular cycle. Its characteristics can be monitored in a sleep clinic. The technician usually attaches various sensors to the body. These help monitor airflow through the upper airway, respiratory effort, audible noise, heart rate, oxygen level in the blood, and electrical activity in the brain. The signals you will see and the sounds you will hear during this presentation are like the ones used to assess your breathing during a sleep study. When you drift off to sleep, most of the muscles in your body relax. However, there are exceptions, such as the diaphragm and, to a lesser extent, the dilator muscles, which control the tongue and soft palate. The diaphragm is assisting our simulated model to breathe normally. The dilator muscles, too, are at work, holding the upper airway fully open. As air flows freely and evenly into and out of the lungs, a typical bell-shaped curve of the airflow is seen. The air flows because of the bellows effect of the diaphragm muscle, which sucks air into the lungs. The respiratory bands attached to the chest and abdomen are measuring the effort required to breathe. They produce two traces, which rise and fall along with the airflow trace. Notice how the airflow and breathing effort traces move in sync. You can actually hear these correspond to the sounds of our model breathing in and breathing out normally. When you are sleeping normally, your heart rate is stable, the oxygen level in your blood remains high, keeping up a normal supply to all your organs. As this EEG trace shows, brainwave activity is as it should be during normal sleep. Normal breathing provides adequate oxygen supply so that all the organs can function effectively. You move naturally through the different stages of sleep and get a good night's sleep. You awake refreshed in the morning and are more likely to remain energetic during the day.